Let's discuss LeetCode problem number 3258, count substrings that satisfy K-constraint. Basically, we are given a binary string like this. Now we need to count the total number of substrings with the following constraint. When k equals to 1, in this case, the number of zeros in the substring is at most k. The number of ones is at most k. So if you take a substring, like, which is a very good example, 101, it satisfies the condition because even though the number of ones is more than k, because 2 in this case, but the number of zeros satisfies the condition is at most k, and k is only 1, so 101 has only 1 0, so it satisfies that condition. So given these constraints, you need to calculate the total number of substrings. So let's take a look at the solution. So we use the sliding window approach, and to calculate, basically you start off with L equals to 0 and R equals to 0, and then keep checking if there is, if keep increasing R until you fail the condition, and then you move the left until you once again the constraints are satisfied, and then you count the number of substrings using this formula. So you start off with count. You have a list which count the number of zeros and the number of ones. You start off L equals to 0 and the total number of substrings as 0. Now you start moving R through the string, the binary input string, and then you set the count of whatever is the first character in the binary string. You set that to increment that, and then now you check the condition while count 0 is greater than k, and so this is critical. This is what makes that 101 a valid string, and count 1 is greater than k. Then basically you reduce the lth position, where the beginning window, when you slide, whatever is the string, you reduce that, either it is 0 or 1, and then you increment the left. And once this condition is satisfied, then you can calculate the number of substrings within that current snapshot of the sliding window as R minus L plus 1, and then you keep accumulating the R minus L plus 1s in each of the iterations, and then add them to the result, and then that's the result you return. So let's take a look at that first LeetCode example, sample run, and k equals to 1. So input string is 10101, and then k equals to 1. So initially R and L both are zeros. So when it is zeros, so the only substring is 1. So R is 0 and L is 0. And so the total is 1 minus 1 plus 1. So 1, and the substring is 1. Substring is 1. So when the window is expanded to 0 and 1, when R moves by 1, so both of them 1 and 0, the count becomes 1 and 1, because you've seen 1 0 and 1 1. And then R equals to 1 and L equals to 0, R minus L plus 1 is 2. So the two substrings are 1 0 and 0 in this case. So let's take a look at 0 2 is a similar, because you don't find any the constraint violations. So you pick up R minus L. L has not moved. Only when the constraint is violated is when the L moves. So 2 minus 1, 0 plus 1 is 3, and the three substrings captured in this iteration are 101, 01, and 1. So the total result at this point is 6. So when window is expanded to 0 3, that's when the count becomes 2 and 2. So both counts exceed k, and then now you start shrinking from the left. So window shrunk from 1 through 3, and then the count becomes 2 zeros and 1 1, and 3 minus 1 plus 1, so it becomes 3, and then you get 0 1 0 1 0 and 0. And so the valid substrings in this iteration are 3, and the result is 9. So Continuing like that until R reaches the end, you will accumulate up to 12 substrings, and that's the answer in LeetCode website. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.